Welcome to my math online class. With me here, your teacher, Mr. A+. Today we are looking at this question. Okay, so this question is coming from paper 1 2025 GCE, as you may see there. So now, and it was question number 12. Okay, both A and B. So let's start with A. If a machine that loads Mary Meal into 25 kg bags has a tolerance of 0.5%, find the highest acceptable mass of any bag that loaded by this machine. Okay, so the first thing here to know is tolerance. So tolerance, this is the space that is given to every machine. Okay, in case of anything, even a vehicle, motorbike, anything to do with the engine, the machine has got a tolerance. Okay, so this tolerance is very important because it helps that particular machine to perform even when it loses its control. Okay, to be able to do what? To perform because of the same tolerance which was put there. So now, this tolerance is the one which we have to this machine, okay, into 25 bags, okay, 25 kg bags. So now, for us to know the highest acceptable mass of any bag loaded by this machine, meaning we have to find the 0.5% of 25 kgs. Then thereafter, you see what to follow. Can you pay attention and follow what is happening here? So how are we going to do it? So we are going to say 0.5%, which is tolerance of 25 kgs. So let's find this now. Okay, because what we want is to know the tolerance which was there in 25 kg. So now we say 0.5 over 100 then times 25 kg. Remember, of that is time, then percent is over 100, and that's what we've done. Then from there we can simplify further. What do we do now? Okay, so here this is where we are going to multiply 0.5 times 25. What is the answer? We are going to find that the answer here is 12.5 in over what? 100. Okay. Then from there, because what we did like this. We multiplied 0.5 times 25, 12.5. Then 100 times 1 is 100. Then from there now, you divide. What are you going to have? Here, remember, since we have one decimal point and we don't have a calculator, this is paper 1. So we are going to convert this one from a decimal number to a whole number by multiplying with the 10. Why are we multiplying 10? Because the decimal point there is just 1, which is 5. So this one is representing 1 0 here. Okay, if we add 2, we are supposed to increase, to put 2 zeros, and it was going to be 100. Okay, so now from there, when we multiply this, we are going to have 125 over this one will be 1000. Okay, so this one can be converted into decimal points. So when you convert this one, the fraction, you can say 1000 there, it will be 0. You put a 0 there, then it will be 125 kg. Okay, so this is the tolerance of 25 kg. Okay, after you have done this now, you come to the question. The question, they are saying, find the highest acceptable mass of any bag loaded by this machine. So now the highest, meaning you have to add. So what do? The true value that we have there, which is 25 kg, then let me write it down. So 25 kg plus 0.125 kg. This is the highest now, to be 25.125 kg. Okay, so now the highest acceptable mass of any bag loaded by this machine is 25.125. So if there is the bag that will have more than 25 kg, the limit there is 25.125 kg. Other than this, nothing can be loaded by this machine because this is the highest. Okay, so this is how simple these calculations are. Thank you so very much. Quickly, let's go to question B now. If 12.5 liters of water was poured out of a container containing 12 liters of water. Find the relative area of volume of water that remained in the container. Okay, that remained in the container. So this container contained 20 liters of water. Okay, so now 12.5 was poured out. So what we are going to do is the initial volume there was Z. So when we come here, we say this is A, then B. The initial volume is 20. Okay, so now that 20, the one which was pulled out, 20 liters, the amount of water that was pulled out were 12.5 liters. Okay, was 12.5 liters. So we say now 1220 minus 12.5 liters, because what we want here is to find what remained inside the container according to the question, because they are saying find the relative area of the volume of water that remained in the container. So no wonder why we first have to subtract 20 minus the one which was poured out for us to know what remained. So what remained was 7.5 liters of water. Okay, so now having found the amount of water that remained in the container, we can find the relative area. Okay, relative area. So what's the formula for relative area? So relative area is equals to absolute area over true value. Okay, so now in this case, the true value that we have is 7.5 liters. Okay, so now what about the relative, the absolute area? Absolute area, how do we find absolute area? Okay, so absolute area is actually the difference, or I would say absolute area is equals to recorded value minus true value. Recorded value minus true value. Now in this case, are we given recorded value? No. So how do we find the absolute area? So absolute area now here is going to be found by considering the least unit of this value which we have. Okay, the least unit. So the least unit of this value is 0.1. Okay, 0.1. So 0.1 times 0.5, because it is always given n over 2, which is 0.5, or 1 over 2, which is 0.5. So we are going to say 0.1 times 0.5. The answer is going to be 0.05 over this is going to be the relative, or absolute area. Okay, so absolute area in this case is going to be 0.05. Okay, so now the other way of finding the absolute area where you are not given the recorded value is just by considering the number of decimal places that you have on the true value. So in this case, how many number of decimal places do we have? There are only one. So now when writing the absolute area, it is going to be 0.05. Okay, if the number is just the whole number there, you are going to have 0.5. Okay, so this is absolute area. Then from there we come to true value. Are we given true value? Yes, it's there. It's 7.5. Okay, so let's now simplify this. Okay, so that it can maybe remain in fraction form. So what do we do? So we are going to say 7.5 into 0.05. How many times? So here we are saying this same 0.05 can go into 7.5. How many times? Here it can go one time. Then here it can go into 7.550. Okay. Therefore, the relative area. So this is our relative area. So don't waste time. This is the way to go. You have to be very sharp in terms of calculating numbers, division, those 4 basic arithmetic operations that we have in mathematics. You have to master them. train your brain to calculate decimal numbers, divide them. Okay, so if you are to take time now to calculate this one, automatically you still get back to the one that I've given you, which is 1 over 150. Thank you so very much. Don't forget to like, share, and comment for more educative videos. Thank you.